Hey everyone, and welcome to this explainer. I am absolutely thrilled to have you here today because we're going to demystify two massive, game-changing concepts in modern computing: infrastructure as code and Terraform. Now, if you've ever spent a super stressful Friday night manually clicking through cloud dashboards, trying to configure a dozen servers, only to make one tiny little human error that brings the entire system crashing down, well, you are going to absolutely love this. We're building your understanding from the absolute ground up today. You don't need any prior knowledge of Terraform to follow along, just a curiosity to learn exactly how massive tech companies deploy thousands of servers without breaking a sweat. Okay, let's take a super quick look at our roadmap. We're going to cover Intro to IaC, Terraform state, secure development, automated inspectors, securing the runtime, and finally, next steps.
All right, let's jump right into Section 1, the blueprint, Intro to IaC. So, think about trying to build a giant apartment complex, right? Brick by brick, pipe by pipe, completely without a master plan. It would be total chaos. Well, in the cloud computing world, infrastructure as code, or IaC, is that perfect repeatable digital blueprint. As the definition says, IaC is software-defined infrastructure. It essentially allows you to write simple, human-readable code to define exactly what you need. Instead of physical bricks, your code defines things like AWS EC2 instances, virtual private networks, and SQL databases. You literally just write a text file, and your cloud provider builds the digital apartment complex for you, incredibly fast and with absolute consistency.
This comparison really hits the nail on the head when we look at the old way versus the new way. In the past, managing infrastructure meant logging into AWS or Azure and manually clicking through endless, tedious menus just to create a server. It's so slow, and it's highly prone to human error. Plus, if a server crashes, you're stuck relying on your memory, or worse, outdated documentation to rebuild it. But with automated IaC, if a server dies, you literally just run your script again. It eliminates the guesswork, perfectly recreates your environment, and cures those 3 a.m. panic attacks for good.
Moving right along to Section 2, the map, understanding Terraform state.
Now that we have our blueprint, let's look at the secret engine that actually brings it to life. Think of the state file as Terraform's master ledger, or a highly detailed map. Terraform uses this JSON text file as its absolute source of truth. It keeps track of exactly what exists out there in the real world versus what your code says should exist. So for example, if your code says you need 5 web servers, but the state file looks out and sees that only 3 are currently running in your Azure account, Terraform immediately knows, hey, I've got work to do. Without this file, Terraform would literally have no memory.
And before Terraform actually makes any changes to your cloud environment, it beautifully executes these 3 core steps. First, it does a refresh to update its map by checking your real live infrastructure. Second, it maps the resources you declared in your code to those remote objects. And third, it does what's called a Terraform plan to show you the exact difference between what is running right now and what you've coded. Once you approve it, it executes a Terraform apply to make reality match your blueprint. It's incredibly smart because it only ever changes exactly what is necessary.
But listen up, because there is a massive security caveat here. As this quote straight from the HashiCorp documentation points out, you have to be extremely careful where you store this file. The reality is, state files often contain highly sensitive data. Stuff like initial passwords or database tokens, right there in plain text. If you push this file to a public GitHub repository, you might literally be publishing the master keys to your entire database for anyone on the internet to find. That is exactly why HashiCorp strongly warns against storing your state in standard version control and urges you to use a secure remote backend instead.
Which perfectly sets up Section 3, developing secure infrastructure.
It's a really fascinating question, isn't it? I mean, if we are suddenly deploying hundreds of servers and databases automatically, just at the push of a button, how do we make sure we aren't just copy-pasting terrible security vulnerabilities at a massive scale? Automating a bad process just means you make devastating mistakes infinitely faster. We need a really solid proactive strategy to make sure our code is rock solid from day one. To solve that, we turn to the Open Worldwide Applications Security Project, or OASP. Their cheat sheet gives us these absolute gold standard best practices for the development phase. First, leverage IDE plugins right inside your code editor to catch risks super early. Second, build threat models so you actually understand your high-risk areas. Third, keep secrets out of your code entirely. Use tools that ensure passwords are never exposed. Use version control for tracking changes. And finally, always enforce the principle of least privilege. This just means your automated script should only have the exact keys to the specific doors they actually need to open and nothing more.
Now, as we move into deployment, inventory management becomes absolutely critical. When you commission a resource, track it.
When you decommission it, securely erase it. But during the actual deployment, proper tagging is your absolute best friend. Asset tagging prevents what the industry calls ghost resources. These are untagged assets that drift away from your code, become impossible to monitor, and quietly drain your cloud budget. Imagine finding out you've been paying thousands of dollars a month for a massive test server that someone just forgot to turn off 6 months ago. So, golden rule, always tag everything.
Okay, let's look at Section 4, Automated Building Inspectors.
To catch those misconfigurations early, we rely on static analysis tools. Think of static analysis like running a brilliant spell checker on your architectural blueprint before you ever start pouring the concrete. It reads your code to find vulnerabilities without actually executing it. Two amazing open-source tools for this are Checkov and TFSec. Checkov is incredibly versatile. It scans Terraform, CloudFormation, Docker, you name it, and offers a massive 750-plus predefined policies. Then you have TFSec, which is razor-focused just on Terraform, deeply integrating into the configuration language parser to catch security issues seamlessly. Both are just brilliant for ensuring compliance before anything actually goes live.
And that brings us to Section 5, Securing the Runtime.
So what happens to our infrastructure security once everything is live out there in the cloud? Well, this brings us to the core philosophy of IaC, immutable infrastructure. Let's use a famous industry analogy here, pets versus cattle. In the old days, servers were like pets. We gave them cute names, and if they got sick, an engineer would log in and nurse them back to health with manual patches. With immutable IaC, servers are like cattle. We do not fix broken infrastructure, no deviations, no manual changes. If a server acts up, we just destroy it and let Terraform provision a fresh, perfectly configured replacement. It guarantees your live environment always matches your secure blueprint.
But you definitely still need eyes on the ground. OWASP recommends strict runtime security measures. You want to enable comprehensive security and audit logging to track exactly who is doing what. You've got to deploy continuous monitoring to keep a protective eye out for compliance violations. And finally, implementing runtime threat detection is crucial. This helps recognize unexpected behaviors. Like, imagine if a rogue user suddenly tries to install cryptocurrency mining software on your web server. This alerts you the absolute moment that threat emerges in the wild.
Finally, Section 6, Next Steps.
We have covered some fantastic ground today, from the basic blueprints of IaC all the way to the automated inspectors that keep our code secure. But really, this is just the beginning of your IaC adventure. I hope you're excited to learn more, because our next lesson on Terraform architecture and workflow is going to be absolutely brilliant. We have the blueprint now, sure, but how do dozens of engineers collaborate safely at scale? Imagine 3 developers trying to update the exact same cloud firewall at the exact same time without overwriting each other's work or crashing the whole system. It's a massive challenge. Think about how you might solve that, and I will see you in the next explainer to uncover the answer.